Hello and welcome. I'm Brian, the Clueless Guru, and today I'm excited to introduce you to the world of NMAP. So, what is NMAP? NMAP is a powerful reconnaissance tool that should be in any geek's toolbox. This is a tool that allows you to get a lay of the land, to get a better understanding of your network, and this is a tool that should be used by system administrators, network administrators, security researchers, and even somebody who runs their own home network. So this is a tool that allows you to identify the hosts that are on your network, what services are on there, and also help you to get additional information about those hosts and what they're running. With this introduction, we will be going into NMAP and using probably about 99% of the commands and parameters that I use. It's a very simple and straightforward tool. It just can be overwhelming when you first look at it. So we're going to break it down. We're going to talk about each of the flags. This talk is primarily going to be for somebody who is new to NMAP, but I hope to also provide some additional information to those who may have some experience with it already. And I'm hoping to fill in any knowledge gaps that you might have. With that, let's jump into it, and we'll start off with the most complicated use case. When I say most complicated, I mean in what we're going to be learning. So here we stack a bunch of flags together to do what it is that we need to do. And when you first look at this, if you're wondering, oh no, this is going to be way too tough, great, because we're going to go through each one of these, and by the end, this is going to make sense. So let's jump into just getting help. So what we're going to do is we're going to jump into the console, and right now we're just using a standard Kali build. And this is going to come with NMAP already installed. And so let's open up a console, which we've already done, and we're going to type in nmap -- help. So now if you look at the results, you see a lot of flags to pick from. And at first glance, this is going to look overwhelming. What do I need? What makes sense? What am I going to miss if I type something in wrong? So as we can see, at the minimum requirements is NMAP and your target specification. Everything else in here is going to be optional. So for the bare minimum, what we're looking at is specifying NMAP, and then I know that I am on the 10 network, so 10.0.0.0. So my IP address on here is 10.0.0.10. And what we're going to do is we're going to scan just our network. I know that I am on a Class C network, which means that it will have a CIDR of 24. And in other words, that also means that it has a net mask of 255.255.255.0. Ultimately, what it really means is that we have a network range that goes from 10.0.0.0 to 10.0.0.255. And so what we're doing is we're specifying to say, hey, scan this entire range. So instead of /24 for the CIDR notation, CIDR, we can actually just go in and say 0 to 255. Out of personal habit and consistency, I just do /24. If you want to do other network ranges, larger network ranges, then you change that number depending on how your subnet is laid out. So let's run this command, and we're going to give it a moment to do its thing. Now that we have our results back, it looks like it only took about 7 seconds to scan, and we have a handful of hosts that showed up. 10.0.0.1, 10.0.0.10, 11, 12, 13. And then we also see that there are a lot of ports listening on these addresses. And basically what a port is it is a service that's running on the host that allows other machines to connect to it. Or in a few edge cases where it can run locally and only itself can, the machine can only talk to itself. But in this case, it's think of it as like a door to a house. It's an entry point into the house to do a particular function. So for example, if we look at port 80, we see here that this is defined as HTTP. So that's going to suggest we're going to run a website on this port. And that'll help us a little bit later to figure out maybe what we're trying to find. Whether it's I plugged a new device onto the network and I'm looking to see where is it, what IP address it might be, and what ports it's listening on. And so this would tell us, okay, this is one of the devices on the network that's listening on a web port. And then we would open up a browser and navigate to it and see what it looks like. So for the purposes of our conversation today, we are going to work on our first flag. And now with this first flag, it's going to be to specify the scan type. And so the scan type we're going to specify is a Syn Scan, or synchronize. And what this is going to do is, with this type of scan, when it goes out to look at different hosts and probe for the services, it's only going to half open a connection. What that means is when I go to scan it, let's say, for example, this 13 host, we scan port 80, it's going to go out to that port and say, send out a synchronized packet or Syn packet. And if that service is listening, it's going to respond back and say, I synchronize and I acknowledge you. And so that's a Syn ACK. And then with this Syn Scan, our conversation is going to stop there, and we're going to move on to interrogating the rest of the ports. So let's get started. One caveat with the Syn Scan is that it does require elevated privileges in order to run. So with that, we would have to specify sudo nmap dash lowercase s, capital S, and the host that you want to scan. For the sake of time, we will just specify the 13 host to do the scan instead of scanning the entire network. And here we go. We have our results back in 1.3 seconds. And it pretty much looks exactly the same. And that's okay, because those ports are going to be there whether we do a Syn Scan or the next one, a TCP Scan. So what a TCP Scan is going to do is it's going to do pretty much the exact same thing, except it's going to finish that handshake. So there's 3 parts to that handshake, where the Syn Scan only does 2. TCP will do the 3rd part. So I send out a synchronized packet, a Syn packet, to the port I'm talking to. It responds back and says synchronize acknowledge, or Syn ACK, and then I send back an acknowledgement packet, an ACK, and that at that point our connection has been established. Now, some differences between these two scans, why would I do one over the other, is because a Syn Scan is typically going to be faster, especially if you're doing larger scans. It's also considered to be stealthier, just because when it crosses a firewall, it tends to log differently than a TCP packet does, a full TCP connection. And that's also another caveat, is what privileges do you have? If you do not have administrative privileges, then you can only do TCP and not Syn Scans. And so let's just do a quick TCP scan, and I would suspect it would look exactly the same. And look at that, it's exactly the same. So we've covered TCP, and something slightly less common, but can still be very valuable to know, is going to be UDP. And so that's going to be the SU flag. And so with this flag, what we're looking at is, with TCP in Syn, we would always send a synchronized packet and then get a Syn ACK back, and then ACK back again. But in this case, with UDP, UDP is a connectionless protocol. So what will happen is I will send something to a UDP port. It may or may not respond. And so now I have to sit there and listen for a moment to see, is it going to respond or say anything? And if it doesn't, we move on. But if it does, then we can mark it as open. So that kind of makes it a little tricky on some networks, especially if it's a busy or unstable network and you don't get that initial response back right away. Sometimes UDP ports can be lost in that scan. So your mileage may vary. But again, if you're doing research, for example, security research or a system admin, it might be a good idea to know what services are running on UDP. Let's get a UDP scan going, and we'll run it on the same host. Now, as you can see, similarly to the synchronize or Syn Scan, you have to have elevated privileges. So we throw sudo in front of it, or we log in as an elevated account. Either approach works. And so we saw before that the TCP scan only took 0.22 seconds to run. But it looks like we're already past that 0.22 seconds on UDP. So it can be a little bit slower. And again, that's just to wait for something to possibly respond back. So let's wait and see what happens. And now our results have come back. And as you can see, it took over 1,000 seconds for this to complete. And that's because we had to sit and wait to see if UDP was going to respond back to us. And in this case, it looks like that we do have a handful of UDP ports available. So things like DHCP or TFTP or NFS or a bunch of other services. We don't need to go into the details as to what those are quite yet. That'll maybe be for another video. But for today, that is what the UDP scan results look like. So now that we see all these different ports that are popping up, maybe you're only interested in a single port. So what we're going to do is we are just going to narrow it down to a select list of ports that we're interested in. And with that, it would be simply NMAP-P and then the port number that you're interested in. And so for example, by default, NMAP is just going to do like a scanning the TCP ports and not UDP. So let's specify ports 80, 443, and 445 as a listing of ports. And then we're going to scan our network as well. 10.0.0.0/24. And now if we perform the scan, 4 seconds later, we have our results. And so what we see here is a listing for every address that was found and whether or not those ports are open, closed, or filtered. And so that shows us the specific ports that we asked for across all of these different hosts. Some other things that you can do is specify by a single port, like port 80, or a range of ports, for example, 80 to 100. And you can also kind of mix and match. So you can say 80, 443, and 100 to 1,000. And all of these ranges would be acceptable and would work. One little trick that not a whole lot of people know about is a shortcut to specify all of the ports. So most people, what I see them do is specify 1-65.5.35, specifying the entire listing of ports available. Another technique to do this is simply do -p-, and that will specify every single port across all of these hosts that you want to scan. That's going to take a little bit of time, so we're going to skip that one, but the output is going to look just the same as this, except with a lot more ports listed out. So what if we're interested in only the open ports and we're not so much interested in the closed and filtered ports? So we'll go back to looking at 443, 8080, and 445 as we saw previously. And what we're going to do is we're going to also include the -- open flag. And let's do our scan. And so as simple as that, we get our results back, and it's narrowed down to just the hosts that have those ports open and showing you which ones they are. So now we're not inundated with a bunch of IP addresses that aren't related to the ports that we actually care about. When we do some of these scans, like as we saw with the UDP scan, If you have a lot of hosts or more aggressive scripts, sometimes it can take a long time to run. So what we can do is we can actually specify a timing flag. And with this timing flag, you can specify a number between 1, which is being super polite, as NMAP puts it, to insane, or level 5, and any whole number in between. So by default, NMAP will use -T3 for speed, and that's just the normal speed. And so if you want to speed it up, then you crank it up to a 4 or a 5. So what a 5 is going to do is it's going to send as many packets as possible down the pipe and try to get the response as quick as possible and get your scan done right away. On the inverse, a T1 is something where it's going to send a packet here, wait a while, send another packet, and then a while later, another packet. And so in some cases where it would take a scan a matter of maybe minutes to do, this instead would take days to perform. Why would you want to do a T1? Well, some examples would be if you are trying to be just extra quiet, extra polite, and you can do that. Certain mechanisms don't pick up on those things quite as easily. And also, more importantly, for stability reasons. For those rare systems that if you even look at it, it tends to fall over, this is something like a super paranoid mode to do. Typically when I'm doing most of my scans, I like to just put it on a T4. And with the size of the scans that we're doing here, we're not going to see that much of a difference in speeds. But for the sake of completeness, let's specify a T5 scan on these ports. And so originally it was 3.84 seconds to run, and now we cut it down to 3.01 seconds. But let's shorten it down to T2, and let's see how long that takes. A fun little tidbit with NMAP is that while it's doing its work, and you're just kind of sitting there wondering what is it actually doing, you can actually hit a key, like a spacebar or enter. It will give you statistics about what it's currently working on. So in this case here, we're doing a ping scan. And so even as a T2, we're looking at it taking over 5 minutes just to ping the host to see if they're alive. After that, it's going to move on to the next phase and actually do port scans. So we're going to stop this because ultimately it's going to look the same as the prior scan. It's just going to take a lot longer to get there. When we see the ports that are specified here, what we're looking at are assumptions. And with NMAP or on your platform, there's a file that references that says, hey, if it's port 80 TCP, there's a good chance it's going to be running HTTP. 43, 80, so 443 would be HTTPS. And 445, Microsoft-DS directory services. That may or may not actually be what's on those services. So something that we can do is we can actually increase the amount of information that we get, kind of like a banner grabbing type of perspective. And with that, we introduce the SV flag, the version flag. And so what we'll do is we'll kind of keep some of these commands here and just keep things stacked up. And we'll do a T4, and we'll do a version scan all across the network for those 3 ports. As you'll see with the version scan, it's taking longer, even though it's increased the timing. Because what's happening is in the background, it's issuing a bunch of extra requests saying, hey, who are you? Give me any information that you get. Like sometimes you connect to a service, it'll just tell you what it is. Other times it might have to do a couple of requests to actually get that information. And so now we have our results back. Now port 80 here still says HTTP, and 443 still says, well, now it says SSL/HTTP, which is equivalently HTTPS. And the version that's telling us is that it's running Nginx. And typically you'll see a version information that goes with this as well, depending on how the server software is written. And so now we see down here that we have an Apache server running version 2.2.14 on an Ubuntu system. and giving you a bunch of additional information about its configuration. And port 443, this is telling us that it might be HTTPS. It wasn't really able to fully determine what it is. And so that's something that if you need to know more about it, that might require some additional interrogation. And then 445, since this is a Linux box, it's running Samba. Otherwise, it would be like a Windows directory service, as we saw before. But here, this is the Linux equivalent. We wouldn't have known that without doing the version scan. And there's a bunch of different ports that offer different sets of information. This is cool and everything. We have a lot of this information. This kind of information is a treasure trove to pretty much anybody involved, for a system administrator, to a network administrator, to a security researcher, everybody in between. Because now this gives you an idea on what services are running on the machine, what versions are running, and maybe something's out of date that needs to be patched, or maybe something's being exposed that it's not supposed to be. And so now let's take this even a step further and do what's called a script scan. So NMAP includes what's called an NMAP scripting engine. And what it does is it will do additional checks depending on kind of what your goal is. And so there's a generic flag that you can use that will execute any scripts that are relevant to the type of service it discovers. So with that, what we can do is jump up here, and I highly recommend that you also include it with an SV scan as well, because you can stack these, and that version information that gets returned gets fed into the script scan so it can appropriately use the right scripts. So we added in the -SV into our command, and now we run it. Okay, and after almost 30 seconds, our results came back. And so now we see that there's even more information. For example, on this web server that's being ran, it took a look at the HTTP methods that are available and telling us that, okay, trace is available. It's a website, and its title is OWASP BWA, or OWASP Broken Web Application. And as we go down, we can also see additional information. Here's another host, Metasploitable, and it's running SMB, and it was able to get down to the specific version of SMB that's running, and additional information about its protocol and its uses. You are able to specify specific scripts that you want to run, and that's outside of the scope of our conversation today. But that's something that you can go to nmap.org and you can check out all the different types of scripts available. So now we have all these results, and instead of trying to make sure that you don't lose these or copy and paste them or constantly rerunning them to get the results back, you can actually do an output, and you can output it into different formats, whether it's going to be -O, which is the NMAP format, or G, which is the greppable NMAP format, or X, which is the XML format. And the -ON is going to give you a text file that looks just like the output that you see it on the screen. And then -OA says all the formats. And so what we'll do is we'll do this exact same scan, and we're going to specify -OA, and then just give it a prefix of whatever you want it to be. So in this case here, I'm just going to do nmap.demo. I tend to like to use descriptive commands, so I'll do nmap as this is the output from nmap.demo as like the demo file. And then what it will do from here is now it will create a file for each one of these output types. So nmap.demo.xml, nmap.demo.gnmap, and .nmap. Okay, and about after 24 seconds, that has completed. And so from here, what we can do is just take a look to see our results. So nmap.demo nmap.demo, and we see we have our 3 files. So if we just do cat nmap.demo.nmap, it looks exactly the same. Or XML. A lot of things you don't need to worry about quite yet, unless you actually need that file. And then gnmap. Looks a little bit cleaner, but also doesn't have quite the same amount of information as the nmap and XML formats do. So with that, that is nmap in a nutshell. That's about 99% of how I use nmap and doing my day-to-day tasks. And now you know it too. It's very simple and straightforward, as you saw. And sometimes it just takes some creativity to understand what the results are that you're seeing, and some research. Intuition doesn't hurt either. So like I said, this is going to be the tool that you're going to want to make sure you know how to use if you're going to be in a technical field that requires you having an idea of what's on the network, what services are listening, and to also just to kind of show off. It doesn't hurt. And if you like this type of education and the way that it's presented here, please like and subscribe and share, get this name out, and let's see what else we can learn together. And so now get out there, learn, practice, and understand. And I'm Brian, the Clueless Guru, signing off.